what does it take to build web applications for, how do you build web applications that are compatible, right? As web developers, we want our apps as widely applicable, as widely, the more the number of people who can visit your site and have a good experience, user experience of the site, the better for us. So let me ask you, probably start with the question: what is the single most, single biggest pain point for you as web devs? Compatibility. Anybody have any other answers than compatibility? Sorry? Usability. Kind of related issues, right? How do you ensure a good usable how do you build websites which are usable across browsers, across versions of browsers, right? So that's what this session is about, especially in the context of all the hoopla around HTML5, right? So we have all these new technologies that are coming out. They're really fancy technologies, but what does it really mean for us as web devs? Can we start using them? Are there any best practices that we should probably think about while implementing those specifications in our web applications? So that sort of is briefly the agenda. So we'll be looking at what are some of the challenges with using these new technologies, with the new suite of technologies that HTML5 is composed of, CSS3 and ECMAScript. We'll talk about some of the best practices that you can adopt as you develop your web applications to deal with this whole issue of browser fragmentation, right? We'll talk about polyfills and shims. If you haven't heard them before, that sounds like a scary term, but it's a really fun, simple concept. So we'll look at that, and then we'll talk about some best practices to adopt around this topic. So that is the challenge, right? Browser fragmentation. Browser fragmentation is probably a great as end users, right? So that's really good. As end users, we are spoiled for choices. We have so many great browsers out there, and you really pick whatever works best for you. So that's great for end users, but probably not so great for us. Not only do we have the problem of having to support different brands of browsers, we also have the problem of having to support different versions of different brands of browsers, right? So not only do we have to support IE, I have to support IE 6, maybe 7, 8, 9, Firefox 3.6, blah, blah, and Chrome, I don't even know what version they are on right now. I think 17, 18 maybe. So I guess the short, brief description of that is it's a mess, right? So we have this huge corpus of users who might come and visit your site on whatever browser they want, and we have the responsibility of making sure that the user experience is acceptable on all of those different browsers. And really, what is the challenge here? All these different browsers, if they had all agreed on a single standard and they implemented that standard, that would be nirvana for us, right? Unfortunately, that's not the case. Different people have different interpretation of what the standard means. Some blame can be placed on the W3C itself, which before HTML5 tended to be kind of ambiguous with many of their specifications. And each browser vendor or implementer could interpret that spec in their own way, and they implemented it in their own way, and then we had different behaviors, and then we had to work around those behaviors, and that was the main challenge. And if you have to kind of keep track of all these different differences in behaviors, it's like you probably need some superhuman strength to do that. That's the challenge, right? So this particular little pie chart here kind of shows you what is the browser market share, right? Updated it for March 2012. And what is a single conclusion that you can draw by looking at this picture? Can we say by looking at this picture, okay, now that single browser, if I build my site for that, I'm done? Can we say that? We cannot say that, right? So if I just stick with IE8, I'm ignoring 75% of the web, right? Not good. And same news for Chrome and Firefox. They all have significant enough chunks so that we cannot ignore them, right? So this is basically the issue. So how do we deal with that? So as I was saying, not only do we have to worry about different browsers and different versions of each browser, of late, something that probably Google Chrome has set this tradition is that the cadence of releases of browsers has also increased, right? So Chrome now does invisible updates, so you don't even know when your browser is new, right? It just automatically happens, which is great for end users. But Firefox, has increased the rate at which they ship versions. Microsoft has increased the rate at which we ship versions, right? So IE9 was last year. We're already talking about IE10, and IE10 Platform Preview 5 is out there, and that brings a whole new set of features to the browser. So some of the things that we have traditionally done to deal with this whole problem is we would build applications to optimize for specific browsers and specific browser versions. So we would write code to detect or to sniff what is the browser, right? How many of you here have written code that says if navigator.useragent. Index of a substring is blah, then do this, else do that. How many of you have done this? Okay. I guess the people who did not raise their hands are too ashamed to raise your hand. Don't feel ashamed. I've done it. Everybody has done it. That's a bad idea, right? So that's something that's bad. It's a bad idea because it's very hard to do. Because what it essentially means, if you write code like that, is that you take upon yourself the onus of keeping track of what browser has what what feature implemented in what way, right? And that, if you think about the number of brands, number of versions, that's one gigantic Excel sheet matrix, right? So I have like browser brands, browser versions, feature matrix, and then you have to keep track of who did what, and then I have to translate that into one gigantic switch case or if else, right? That's the sort of work that can make grown people cry. So that's where the idea of feature detection kind of comes into the picture. So I kind of want to introduce a library called Modernizer. Probably many of you have already heard about it. Who has not heard of Modernizer here? Okay, we have a reasonable chunk of folks who haven't heard about Modernizer. Now the basic idea here is doing browser version detection is not a good idea. It's way too hard to do, right? It's simply not practical. So what can you do? So the best practice approach for dealing with this whole issue of browser fragmentation is don't worry about versions, right? Don't worry about what the browser is, what the version of the browser is. Look for, try to sniff whether the browser, whichever it is that is currently running, has support for the feature in question, right? So let's say you are building an application that needs support for HTML5 canvas. Instead of saying, if the user is running Chrome, or if the user is running Firefox, if the user is running Safari, if the user is running Opera, and these versions, then I'll use Chrome, then I'll use Canvas, right? Instead of writing code like that, write code which helps you check whether the browser supports Canvas, and if yes, use that, otherwise not, right? So that's called feature detection and not user agent sniffing. Essentially, code that, this is probably the way we've been writing the code, right? Navigator.useragent.index-of-MSIE, and if that is not found, then I say window.add-event-listener. This basically I'm trying to attach an event handler for the load event on the page, right? So what I do is, if it is not IE, then I basically call add-event-listener, which is the W3C standard way of adding event listeners for different events, and then I do that. And I say else, if the window object has a attach event property, then I go do that. Now here the thing that I'm doing here is I'm trying to see if the user agent is IE, and based on that I make some decision, right? Don't do this. What you should instead be doing is something like that. So here all that I'm doing is that I'm checking whether the window object has a property called add-event-listener. I just say if window.add-event-listener, which means that the window object has that property. I really don't care what the browser is, right? All I'm interested in is see if the feature, if the capability that I'm looking for is available in that object or not. If yes, then I go ahead and use it. Otherwise, I check if attach event is there, and then I go do that. Now, the reason why the previous code that I showed you is not a good idea is because browsers don't remain static, right? They evolve. So that code was checking whether the browser is IE, right? And if it is IE, assume that there's only attach event, no add-event-listener. Add-event-listener is the recommended way of doing things. And that's a bad idea because IE eventually got support for add-event-listener. From IE 9 and up, add-event-listener is available in the DOM, right? You can call that to attach events. And attach event is deprecated. You're not supposed to use it. In a future version of the browser, it might go away. But if you had written code to assume that IE will always have attach event, then who knows, right? At some future point in time, that might stop working. So don't make assumptions on user agent strings. Look for features. To kind of show you what that code would look like, let me just quickly show you that. So here's a very simple page. There's nothing much going on here at all. It just has a body tag, a ahref, and then all I do is I try to add an event handler for that link. And here's exactly the same code. So I say window.add-event-listener, and if that is available, then I say link.add-event-listener. It says you are using a standard compliant browser, blah. So this went into that first loop, right? And if I use my IE10 debugging, so this basically is a feature in IE which allows you to simulate different browser behavior. So if I go to, you can hit F12, go to document mode at the top, and you can select Quarks mode, Internet Explorer 5 mode, 7 mode, 8 mode, 9 mode, and Quarks mode. Quarks mode is a new thing that is in IE10. So if I say 7 or 8, then basically the browser will pretend like it's 7 or 8, and you will see all the behaviors that you saw in 7 or 8. It's a quick way of testing your app and see how that looks like in older versions of IE. So I go and click that same link here. It says, not standards compliant. Basically now window.attach event listener, add event listener is gone. Right now it's using the attach event variant. So that might not seem like a big deal, right? Okay, I mean, that's fine. But that's probably a very simplistic example that I took, right, to see whether that particular method is available. What else can you do? In this IE10 has support for these semantic tags. I'll go ahead and switch the mode here. I'll probably dock it to my IE window itself. I'll probably minimize that. All right, so I'm just going to change that to IE7, and that's what that looks like, right? So here, basically IE7 rendering mode just ignores the semantic tags. It doesn't know what to do with header, just ignore it, and takes the text. It recognizes H1, so the H1s get rendered properly. Everything else gets rendered with just the P, the paragraph tags. So not so good, right? So what happens when I go ahead and include this, right? So I go ahead and include that, and I hit F5. It's still not exactly the same as what we saw earlier, if you watch closely, right? So for example, in the standards mode, you see there's a little shadow here, there's a border radius here, right? A bunch of new features that are there in CSS3 and HTML5. I've used that to style this page. It doesn't look quite the same in IE7, but you know what? I think this is completely acceptable, right? It's not that bad. And people who are still in IE7 should suffer, right? So they should get a new browser, they should upgrade. But this is still an acceptable user experience, right? It's not completely down the drain. So that's something that Modernizer gives you out of the box for free. So one thing that I quickly wanted to talk about while talking about CSS3 is with regard to vendor prefixes. So one of the things that browser vendors have done with CSS3 is that they want to push out features as quickly as possible, right? So when the W3C sits together, comes out with a spec for a new kind of thing that you can style, all browsers just start implementing it, and then they want to push it out to end users, and people can start using it. The idea is these specifications are still not final, right? So they are still in working draft, they are still being discussed, there's a lot of churn happening in the spec, but they want implementation experience. They want browser vendors to implement the particular feature in question, and they want web developers to use it, and they want feedback, and then they want to refine the spec again. So how does this process work? So browser vendors will implement those particular relevant CSS feature in question with a prefix. So for example, so these are some of the common prefixes, right? So Microsoft's implementation will prefix your strings with -ms-. WebKit is for Chrome and Safari, Moz is for Firefox, and that's great. So you get to experiment. Folks who are on new browsers, they get the nice enriched experience. Folks who are not, the browser would just ignore these rules because the browser does not recognize the rule. It will just ignore it. What is probably, this is a point I want to make. As web developers, there is this tendency to support only WebKit vendor prefix. In fact, recently Mozilla and Microsoft in a recent W3C meeting kind of threatened to support the WebKit vendor prefix in IE and Firefox. Right? Now I think that's not a good idea at all. And I think as web developers, the onus is on us to make sure that does not happen, right? See, browser vendors are ultimately, it's also a business. The browsers are free, but it's a business. It's a platform, right? We want people to be on the platform. And it's never a good idea to have any particular W3C spec dependent on one particular platform, right? And we've been there. Anybody remember where we've been there before? IE6, right? So IE6 became a pseudo platform, right? Where Firefox started implementing, IE6 became the standard. Firefox would implement stuff the way it works in IE6 because the reason was web devs optimized their web applications for IE6. So the browser vendor has no option. If they want to remain competitive, they have to make sure that their app looks, they'll say, okay, Firefox, the website looks like crap. They're going to blame Firefox. They don't want to say the web dev who made the site and made it optimized for IE6, right? There is this trend that we are seeing now where people are doing the exact same thing for Chrome. So people use, for example, with vendor prefixes, the story is people use WebKit. They don't use Opera, they don't use Firefox, they definitely don't use Microsoft's -MS-. And this is compelling browser vendors to again consider approaches which are probably not good, just to remain competitive. So obviously that was shot down, that proposal to support WebKit vendor prefix in Firefox and IE. But as web devs, I think, and I just want to put out this message that we need to make sure that, if you are implementing vendor prefixes, please make sure that you implement vendor prefixes for all browser vendors, and that's a good thing for you because all browsers, no matter what browser the user is coming on, they get that same experience. Otherwise, even if the browser supports it, they're going to ignore the WebKit vendor prefix and they just don't get that experience. Don't make Chrome the new IE6, right? So that kind of is the message that I wanted to pass there.
How do the vendors know that? How do they get the statistics that they use?
How do they get the statistics? I guess they can crawl the web and find out. As in, what is the actual question? Like,
So basically, how do the vendors basically find out what is the prefix that's being widely used? Is it possible?
So see, the objective behind vendor prefixes is so that the W3C gets feedback from the browser vendors and from web devs regarding that feature. So let's say Rev1 of border radius was specified in a certain way, right? So Chrome and Firefox go ahead and implement it, but it's not a final spec yet, so they implement it with a vendor prefix. So they'll say .mos-border-radius, .webkit-border-radius. People implement it and they give feedback, right? They say, hey, no, hold on a sec, we need another attribute to control this particular aspect of the border radius. So they give the feedback to the browser vendor and to W3C. W3C refines. So this whole process keeps happening, right? So that's the idea behind the whole thing. So it's not like, so the idea is to just get that feedback and refine the spec, right? So what happens is some feature, because of the popularity of the browser, that particular prefix becomes so widely adopted that becomes the pseudo standard, right? Because developers, even they refuse to implement the W3C version of that rule, right? So the best practice when you're using vendor prefixes is always use the W3C name of that particular rule last. So if you're using border radius, put dash webkit dash border radius dash mos dash border radius. Make sure that you put border dash radius in the end, right? That's the W3C name, because eventually when that becomes the spec, your site will start behaving appropriately. You don't have to change your code, right? So folks are not doing even that. So they're just putting WebKit and they're happy because it works in Chrome, it works in Firefox, it works on iPads and iPhones, and it's all peachy, right? But the result is that becomes a standard, a pseudo standard. It cannot be a standard, it becomes a pseudo standard, right? It's a standard by proxy, by adoption. It's not even within W3C's control, right?
Always whenever you use these kind of CSS3 selectors, you always have the default one also, right? It's not just the MS. When you say border radius, you have to always have the
Exactly. So that's my message. So make sure that you use the W3C name. The W3C name is obviously vendor prefix less, so it will be just border dash radius. So make sure that you put it last, in fact. So don't put it border radius, WebKit border radius. Put WebKit border radius, because if you have redundant CSS rules, the last one always wins, right? So you want the W3C version of that particular rule to win. You don't want the vendor prefix version to win. Anyway, so a little distraction from the thing, I guess. Yes?
One way to control it is like from the IntelliSense. When I type it in the Visual Studio or something, when I type border radius, I get a bunch of options, right?
Yes.
One way to control it can be like give me the option, W3 option first. So I go ahead and type that first.
In fact, that's the way it works in Visual Studio. So you can, the snippet is, I don't know, maybe if you've attended some of my other sessions, I've already shown this a couple of times. Sorry?
In VS10, I get the Mozilla border radius option.
You get in VS10, VS11, both. So VS10, you have to install a plugin, extension from Visual Studio Extension Gallery. 2011, it's available out of the box. So if you want to do border radius, so you can say border dash radius, and then you can hit tab again, and then it will generate all the vendor prefixed ones as well automatically for you. I mean, it's ultimately the same rule. You're specifying it 3 times or how many times you want to support for different browser vendors. So you can see that Visual Studio does the right thing here, right? So Moz WebKit, and then it puts the W3C name last, and that's the recommended standard, right? I mean that is the best practice. Moving forward, I just want to quickly talk about polyfills and shims, right? Now this is all great. So all these specifications and the CSS3, is there. You can use it. You can make fancy websites. What happens when older users come with older browsers. So this is kind of the scenario, right? You have this swanky new feature. You want to use that in your web application. As geeks, we are so happy to get new features. We go ahead and we build it, implement it. Wow, it looks great. And then along comes a very old browser, right? And they want to look at your site, and then things go nuclear, right? You don't want that. That's what polyfills kind of help you with. So polyfills is basically a fancy name. It stands for polymorphic backfilling, which is even more scary. But basically what it means is you have all these W3C standards. How can I use them today and provide an acceptable UX for older browsers, right? And they do that by, it's basically a library that just plugs in and provides that functionality for older browsers. For example, I want to use Canvas in my app, right? And the Canvas API is available in IE 9 and up. I want folks in IE 6, 7, 8 to have the same experience. What do I do? So there is a polyfill for Canvas, right? So it's a library basically. So you download the library, integrate it in your app, and what that library would do is it allows you to interface with that particular spec without having to worry whether it is W3C or not. In the sense that the Canvas API is a 2D graphics API. So you can draw lines, you can draw arcs, you can draw beziers, you can do filling, and you can do all kinds of fancy things, right? So there's this particular API. Now what polyfills allow you to do is it automatically makes sure that that Canvas API is available to your web app no matter what the browser is. Okay, it's not black magic. They will rely on plugins typically, right? So if so we'll look at a demo which uses Canvas to see how we did it. So basically what I did there was on newer browsers it would use the native Canvas implementation. On older browsers it would fall back to Silverlight, right? So older folks, to the user it's completely transparent. You don't see what's going on. It just works. But inside what's happening is if it's on IE 6, 7 or 8, the Silverlight plugin gets that gets instantiated and you're able to draw and the same thing works. So something to remember is it's not the equivalent fidelity in user experience, right? The best thing is to have the browser natively supported because user has to do nothing. If you are using, if you're getting support for that particular feature through a backfill, through a library, for example, it's through Silverlight, there are other issues that you need to worry about. Does the user have the Silverlight plugin installed? If the user doesn't have the Silverlight plugin installed, what do you do? Right? You have to provide a fallback for that. Does the user have the correct version of the Silverlight that your plugin needs? Maybe you wrote the plugin for Silverlight 4 and the user has Silverlight 2. Issues, right? That's why the world is moving away from plugins, right? If you notice, plugins not supported on iOS, Windows 8 Metro IE does not support plugins, no Flash, no Silverlight. There are issues, right? So, but you know what? This is probably the next best solution, right? Instead of leaving the users dead in the water, there is at least a path for them to get access to your app, right? And for example, Flash is very ubiquitous, right? So there are lots of polyfills that provide functionalities that HTML5 provides through Flash fallbacks. So you get to leverage these new specifications without losing user base, which is always a great thing. And from a development point of view, there is no extra effort. You are developing to the W3C API. So if I'm using Canvas, I'm coding to the Canvas API. I don't have to do anything special to accommodate the plugin, right? To accommodate the backfill, the polyfill. Shims are, it's just again a fancy name for regular libraries. It's very similar to polyfills. The only difference is that a shim does not necessarily conform to any standard. A polyfill will always conform to some W3C spec. It will conform to geolocation, WebSockets. It will conform to that spec, right? Which means that exact API interface has to be implemented by the polyfill. A shim does not. Shims typically tend to be higher level abstractions. For example, there is this shim called as Amplify Store, which is a JavaScript library that provides client-side persistent storage. So you had cookies, right, which is what we used for a long time. Now you have many options. You have DOM storage, you have IndexedDB, you have that's it, DOM storage and IndexedDB. Amplify Store is an API that kind of abstracts on top of that. So it does the best that it can to give you client-side persistence. So it will do whatever is available. So it will do cookies. It will do, maybe cookies are disabled. It will try to use DOM storage. If that's not there, it will try to use IndexedDB. If that's not there, it will try to use Flash isolated storage or maybe Silverlight isolated storage, whatever is available, right? So this is like a high-level abstraction, and the only thing is this does not conform to any spec. It has its own API, but it gives you that feature. So it's just a regular library. The folks who maintain Modernizer have a big list of polyfills in a GitHub page. If internet works, I can show you that page. So while that is connecting, So basically, just otherwise you can take note of that little bitly URL. So this is like a gigantic list of polyfills for all possible HTML5 specs that you can think of, right? So it's a very useful resource to have. Typically these tend to be open source volunteer effort. So like any other open source project, remember to vet the code, right? They don't owe you anything. They're giving you the code. Be grateful for that, but they don't owe you anything. So which means that you have to vet the code, make sure that it works. You may have to support it in the future, right? Other than that, feel free to use polyfills. It kind of is the closest you can get to best of having both the worlds. You get to use new specs and you get to not lose your old user base. So let me quickly show you what this kind of looks like. So I have a page here. I don't think our connection worked. There we go. I'll get rid of that. So this is basically an app that allows you to doodle. Okay, so it's nothing major. So I can just go and I think that color is not very visible. Okay, so I can go ahead and draw stuff here, and this is completely implemented using Canvas here. So that's how you prove it, right? So if it was Flash Silverlight, you would see the Flash Silverlight menu. So you see the IE context menu here. This is just a regular Canvas dialog, Canvas element. So I'll go ahead and change my document mode to IE7. And I get this, and you find that you're able to. I just choose a random color every time the page loads. So sometimes, okay. So you see that I'm still able to draw, right? And for the user, it looks like just works. But now if I right click, you can see that this is Silverlight, right? The application dynamically detected whether the browser has support for the particular feature I'm looking for. In this case it's Canvas. And if yes, then it uses that, otherwise it falls back. So if you look at the code briefly, so if you look at the index.html here, I have a bunch of stuff here. So right here I have the Canvas tag. So older browsers will simply ignore this tag because they don't know what to do with the Canvas tag. Newer browsers will render the Canvas. And then I have an object ID here as well. So this is basically a Silverlight based Canvas polyfill that I picked from that URL that I showed you. There are Flash versions as well. So I just picked that and instantiated that Silverlight plugin here, and then in a little bit of JavaScript, I switch I hide the canvas and show the object tag, or I hide the object tag and show the canvas. That's the only browser bit, customization that I had to do. The core logic for handling the events and drawing, it goes into my doodler.js file here, and so let me just show you that single function which actually does the drawing. So this draw line method here, this is what actually draws the line. And here you can see that I really don't. So this is just a very simple logic. Right? I'm just drawing a line between 2 points. Imagine it's a more complicated drawing, right? So I do lots of complicated mathematics and I do the drawing. That code does not change, right? So if it's a polyfill or if it's the HTML5 implementation, this code remains exactly the same. So that's the benefit of using the polyfill. So there's a little bit of code elsewhere where I swap out the implementations. I think this is it. So here you can see that I use Modernizer to detect whether the current browser supports Canvas. If it does support Canvas, then I return a reference to that Canvas element. Otherwise, I return a reference to the Silverlight object element, right? And that's it. That's the only little piece where I do the browser sniffing. Sorry, not the browser sniffing. I do feature detection to see whether the browser supports the Canvas and do the appropriate thing. Otherwise, the rest of my logic remains exactly the same. And of course, all this works fine in other browsers too. This is Chrome. I get to draw fine, and I don't know how to switch versions in Chrome. Is it possible to do in Chrome? No, right? All right. So that was briefly about polyfills and shims, right? And there are polyfills like this for all, like geolocation, WebSockets, you name it. All right, so since we have about 5, 6, probably 8 minutes, I just want to quickly talk about HTML5 video. Now this is something again that you probably know is probably the most visible part of the HTML5 spec, right? Do you have a question? No? Okay, so this is probably the most visible part, right? So whenever you talk about HTML5, you're talking about video, audio. So now you can do video, audio without Silverlight and Flash, right? The browser natively supports these things. You can just take and play. Now that's great. This is probably the way you wrote code earlier. that looks like a scary amount of code, but basically what's happening here is it's trying to instantiate a Silverlight, XAP, XAP, which is basically the video player, and then I configure it, I pass the path to the video. That's what the new way of doing it looks like, right? So it's a very simple video tag, and you specify the path to the video in the SRC, and you're done, right? It takes the video and it plays it. Or this is the ideal way of doing things. Unfortunately, there is something else that you have to consider when you're talking about video and audio, and that's the codecs piece, right? What codec is the video, compressed or decompressed in? So that's the story right now. So there are three major codecs that we as web devs have to worry about. One is the Theora org container, the Theora codec. This is basically supported by Mozilla. There is support in Chrome and Firefox. There's basically a matrix that shows you who supports what. H.264 is the most popular codec, video codec in the world, and it's supported on IE and Safari, which means on iOS as well, iPads and iPhones. And then you have WebM, which is pushed by Chrome. And the story is evolving still. Okay, so in fact, as recently as last week, I read news that Firefox is planning to support H.264 going forward. Now, the reason why Firefox does not support H.264 is that it's not royalty free, right? It's patent encumbered. So if they are implementing H.264 in their browser, somebody gets some money, right? So Firefox, being an open source project, seeks to be open about everything. They do not want to use any closed source things. They do not want any patent encumbered specifications. Therefore, they have so far on principle refused to support H.264. Google Chrome, for the same reason, is trying to push another spec called as WebM, which again they're pushing as as the patent-free video codec. They have been threatening to drop support for H.264. They haven't done that yet. Microsoft and Apple have gone with H.264. It's a much higher quality codec compared to Theora and WebM, and it is very widely adopted on all kinds of devices that you can think of. Because of that reason, Safari and Microsoft have gone with H.264. But now, this is actually a case where I was talking about implementations driving pseudo standards. This is kind of happening like that. There is no consensus, right? Everybody has their own idea. But because H.264 has so much wide adoption, everybody is doing that, right? So Firefox has now decided to support H.264. Chrome has been threatening to drop it, but they haven't done that yet. So ultimately, as web devs, the brief is we have to deal with this scenario, right? You might have people who don't, even if they support HTML5 video, it might still not play your video. So how do you deal with that? That's how you deal with that. You support everybody, right? That's what makes a life exciting as web devs, right? So if you have the video, you have to encode pretty much as H.264, OGG, and WebM. The nice thing is the HTML5 video tag has support for this, so you can provide the same source multiple times, and the browser gets to pick what it wants to, right? So IE and Safari might go ahead and pick MP4 because it supports H.264. Firefox will pick this. Chrome, it will probably pick H.264 or WebM. I don't know which one it will pick. It supports both right now. But what about old browsers, right? You still have this old guy who comes and tries to play your video tag. They don't even know about video. This video is not like the styling piece, right? It's not enough that you style your video. You still have to play the video. So that won't work. So that's the solution for that, right? You fall back to Silverlight or Flash. That kind of is the story for pretty much everything. And you can give that level of fallback. So this is like how many levels of fallback? Have you seen the movie Inception? It's like dream within a dream within a dream. So you have the video tag. You provide fallback for multiple codecs by providing multiple sources. The video tag might not be supported. So you provide a fallback for that using the object tag, and it could be Silverlight or Flash. Silverlight or Flash might not be there. So you have to provide a fallback for that. You know what the fallback for that is? It's a message that says go get a better browser. So let me just show you what that looks like. So I have a bunch of files here. So I'll open the first one. So I just go ahead and play. It plays the video. So if you look at the source here, it's very simple video. This is an alternate syntax. If you have just one source, then you can give it as an attribute. Otherwise, you can give it as a child tag, and that works fine. So this is obviously IE10. Let's see what that looks like in Firefox. And I'm running Firefox 11. It's downloading the next version as I speak. See, don't blink, you get a new browser. So this supports video tag, right? Firefox supports video tag, and that's what you get. That's because Firefox does not like H.264. So how do you deal with that? So I have video2.html here, and that plays just fine, right? So what is the deal with that? So that's very straightforward. So here I have provided two sources, right? The one is the MP4 for H.264, and then the OGG file for Firefox. And Firefox is happy now; it starts playing the video. So I have a third file here. So I go ahead and open this in IE10. Plays great, just as before. In fact, let me open video 1 in IE10 to kind of make that point. So that plays great. So I'll go here and switch the mode to IE7, and that's what that looks like, right? Doesn't look like a video at all. So how do you deal with that situation? You provide the third level of fallback, and that's what happens here. So here that same video is getting played in IE7 mode, but now you can see that this is Silverlight, right? And if you look at the source code, that's what the source code looks like. So it has a video tag, it has two source tags for H.264 and Firefox, and then we have the object tag for Silverlight.
Does Silverlight give you control over the videos? Like, otherwise you can pause and play, right? So
Yes.
you have those kind of controls.
Yes, you do. You can even script it from JavaScript. So that's unfortunately that's the sad codec story with videos. Maybe someday we'll have consensus. We all live in hope. Hope springs eternal. So with that, I kind of come to the end of the session. There are a couple of resources that I kind of like to point out to you. So Introducing HTML5 is a very nice book by Bruce Lawson and Remy Sharp. This is a book that's put out by a publishing house called as A Book Apart. They also have put many other nice books. In fact, CSS3 for web design is also from A Book Apart. The nice thing about these books is that they are really small, so you can quickly finish reading them. In fact, Introducing HTML5 is about 80 pages. You can finish it in one evening. But the nice thing about the book is it gives you a very well-rounded introduction to what HTML5 is about, minus all the marketing speak. Just get the real picture. What does it take to implement HTML5 features in your web today? Many of the content from this session has been drawn from that book. HTML5 Web Designers is a great resource as well. So if you want to get in touch with me, that's my blog, email, Twitter handle. So with that, we come to the end of the session.